Okay, welcome to the trigonometry review. I'm going to start by talking about different ways we can slice up a circle. You could take a circle and you cut it in half, cut it in quarters. One of the things you learned in high school was that there's this convenient way to cut up a circle into what are called degrees. You cut this circle into, or you slice it into 360 equally sized wedges. Each wedge having this 1 degree little slice, that big. And then you could look at increments of those 1 degree measures. So 30 degrees would be 30 times 1 degree measurements. You could then talk about how many of those 30 degree measurements would it take to construct the entire circle. It'd be 12 of those because 12 times 30 is 360. You'd also talk about 60 degree increments, so larger slices of 60 degrees each slice. Actually, I'll be more careful when talking about subdividing the circle. So that would be a 60 degree slice. How many of those would we need to construct the entire circle? Well, we would need 6 of those. So I'll draw them all in. Okay, this is not anything other than different ways of talking about how to slice a circle up into pieces. Now, in the study of calculus, this measurement of degrees is something we're going to talk about. It's something I'm going to just mention. Hey, this is a 90 degree, this is 180 degrees. But for the most part, we're going to use a competing system of measure that's called radians. Instead of slicing a circle up into 360 degrees, we can slice it up into 2 pi radians. Then, a quarter of a circle, instead of being 90 degrees, is going to be 2 pi divided by 4, which is, we simplify that fraction. So 2 pi is the full circle, divided into quarters, so 2 pi divided by 4. If we simplify that, we get pi over 2. Half of the circle, so we take the 2 pi for the whole thing and divide it by 2. That gives us our pi. And if we want 3/4 of a circle, so 3 over 4 times 2 pi, that's going to give us our 3 pi over 2 after simplifying. Well, the radian measure is going to be the one that we predominantly use. You're going to see that right away. All of our trigonometric functions, including evaluation of trigonometric functions, including our special triangles, they're all going to be posed in terms of radians. And that might be a big departure from how you study trigonometry in high school. What I want to do is I want to practice a little bit of the conversion between degrees and radians. And you're not going to have to do this. This is not something you're going to be asked to do. I'm going through this only to build your familiarity with the radian measure. So if you have a degree measurement in mind and you want to convert that into radians, you do the following. You take your measurement that's in degrees, let's say 40 degrees. That's your x. You multiply it by pi and divide by 180. So let's say your x is 180 degrees. Your radian measure is going to be 180 times pi divided by 180, so just pi. To work backwards, say you have a measurement in radians, maybe 5 pi over 6, and you want to know what does that mean in terms of degrees, because maybe you naturally think in terms of degrees. Well, you take your radian measure, call it theta, multiply by 180, and then divide by pi. So the example given in the red box on the bottom left says, how do you convert 7 pi over 6 radian measure into degree measure? Well, you take your 7 pi over 6, multiply by 180, and then divide by pi. So the easiest way to multiply 7 pi over 6 by 180 is to first divide by the 6. So 180 divided by 6 is like 18 divided by 6 times 10, so 30. Then you have your 30 times your 7 on top, so 210. The pi, top and bottom, cancel. So there's a pi on the bottom because that's part of our conversion formula. And that gives us our 210 degrees. I want to go through a table of conversions from degrees to radians and a few of them from radians back to degrees. Use the conversion formula. So just to make it a little bit more clear which formula is being used. So for degree conversions, I'm going to use this one. We're going to have, for the first entry in the table, our radian measure is going to be 0 times pi over 180, which is 0 over 180, which is 0. That means 0 degrees is the same thing as 0 radians. Okay, next, 30 degrees. So we'll have 30 times pi over 180. So we cancel the 0, cancel the 10, so we have 3 pi over 18. And then 18 is the same thing as 6 times 3. The 3's will cancel, so that's the same thing as pi over 6. That means every time you see a pi over 6 in a calculation, you can mentally convert that into 30 degrees, if that helps you think about what it means. Okay, 45. Well, 45 times pi over 180. Let's see, 45 times 2 is 90. 90 times 2 is 180, so this is a pi over 4, if you do the cancellation there. Okay, I'm going to skip the next one because it uses the other conversion formula. I'll come back to it after doing the conversion after. For 90, we have 90 pi over 180. So 90 is half of 180, so this is going to be pi over 2. Okay, I'll skip the next two because they're also the other order. 270, so let's do that one. 270 pi over 180. So 270 is 90 times 3. So I'm going to write that, 90 times 3 pi. And then 180 is 90 times 2. We can cancel the 90s. So we get 3 pi over 2. So that's how you do that conversion. So if you see a 3 pi over 2, it means 270 degrees. Now I'm going to do the other conversions, making sure I just switch the formula. I'm going to indicate the formula being used in purple. Okay, now I want to work backwards to convert the pi over 3 measurement into degrees. So that's 180 times pi over 3 all over pi. The pi will cancel. So we have 180 over 3, which is 60, because 180 is 60 times 3. 3's cancel. So that's your answer for that one. So pi over 3 is the same thing as 60 degrees. I really should put the little degree symbols here. Okay. Next one for the conversion is 5 pi over 6. So that's going to be 180 times 5 pi over 6. Divide by pi. The pi's cancel again. So we have 180 times 5 all over 6. It's definitely smarter to divide by 6 before you multiply by 5. 180 divided by 6 is 30. And then 30 times 5 is 150. So 150 degrees. Okay, next one, pi. So that's 180 times pi over pi. The pi's cancel, we just have 180. Nothing shocking there. Okay, and then the last one, 2 pi. So we have 180 times 2 pi over pi. Pi's cancel. We have 2 times 180, which is 360 degrees. And again, I want to emphasize this is not something that's really part of the course. I'm only going through this because in high school, you probably spent most of your time in degrees, whereas in this course, we're going to spend most of our time in radians. So if you see an angle measurement in radians, you just might want to mentally convert it into degrees so you can better imagine what's going on. I'm going to continue this in the next video.